Okay, what we're going to look at are some more of our basic integration techniques. And I'm just going to show you 3 examples of different techniques. And the first one is if we have the integral of sine of x over the square root of cosine of x dx. Because cosine is in the square root, what I would do here is I would use a u substitution. That would be my technique I would use, and I would let u equal the cosine of x. And that works because the derivative of the cosine is negative sine of x dx. So then I'm integrating negative, because of this negative, 1 over the square root of u, or u to the negative 1/2. So when I integrate that, I'm going to get u to the positive 1/2 times 2, and it's going to be negative because of the negative in front. So I get negative 2 times the square root of the cosine of x plus c. Okay, let's look at a different one. If I integrate 1 over 4 plus 3x squared dx. If I look at this one, at first I thought maybe I could use a u substitution, but if I let u equal the denominator, my derivative would be 6x, and I don't have any x's in the numerator to get rid of. So that means I have to think of something else. I don't really see much algebra I can do here. If you remember a couple of the techniques they used algebra, used some factoring or multiplying by the conjugate. I don't really see any algebra that I could do there. So what you need to look at is your arc, your inverse trig functions. This one is very similar to the arc-tangent, and so I would let a equal 2, and I would let u equal the square root of 3x. Oops, the square root of 3 times x, I guess. That's not what I wanted either. How about the square root of 3 times x, because you have x squared, so that'll work out. And so if I integrate that, then it says that my answer should be 1 over a, which is 2, times the arctan of u, which is square root of 3x, over a, which is 2, plus c. Alright, let's look at one more. I'm going to use an e. We haven't done e for a while. So e to the 1 over t power divided by t squared. And since we're using t, that would be a dt. Well, when you first look at this, maybe you think that u could equal t squared. But that means du would be 2t. There's no 2t, so that doesn't work. So what else could u equal? It could equal the exponent of your number e. So u could be 1 over t. And when you take the derivative of that, remember that's t to the negative 1, I get negative 1 over t squared dt. So if I move my negative out front, and now I have e to the u over, well, this t squared in the denominator is taken care of by this one. So I just have e to the u over 1, or just e to the u du. And remember, when you integrate e, it's really exciting. You're going to get negative because of the negative in front. If you integrate e, you get just e. So I get negative e to the u. And if I substitute back in, I get negative e to the 1 over t power plus c. So there's some basic integration. Just a quick little review.